All right, so in this video tutorial, we're going to work with ArcGIS Network Analyst extension. We're going to learn how we can build a network based on our own data and then perform different network analysis. In a network, a distance between two vertices or point is not the straight line distance, but it is based on a street network distance, or in other words, it's based on the existing roads. There are five major functionalities in network analysis, which are route analysis, closest facility, service area, origin, destination, matrix, location allocation analysis. And in this lab, we're going to learn how we can build a network data set and then work with two important functions of the network analysis, which are route analysis and closest facility. And in the next lab, we're going to focus on the other functions of the network analysis. All right, so the first shapefile that we will work with is the road shapefile of the Union County in Ohio. If you go to this website that I also provided the link in the description below. So if you scroll down in this website, they have the aerial photography, building and addresses. So these are the GIS data that mostly they are in the shapefile format or satellite images. Hydrography, properties, topography, transportation. So under transportation, if you select roads, so it will download this data. You need to extract this data, and or you can just copy and paste it in your lab, and then in the folder that you saved all of your data, and then extract it. So I already have downloaded and extracted the data. If I go to the ArcMap environment, add data, I have saved it in this direction, and then I can load it into ArcMap. If you open up the attribute table of this data, you'll notice it has over 4,300 records or road segments. And for each road segment, it has shape lengths, the lengths of each of those segments, and also it has some other characteristics, but the one that we're going to focus on is the speed limits. And the units for this speed limit is definitely mile per hour. So first, let's calculate the travel time for each line segment or road segment based on this speed limit. Okay, so I'm gonna add a new field and I'm gonna call it minutes. So I'm gonna find the travel time based on minute for each segment and the data type double and okay. And so we need to calculate the travel time. We need the distance, which is we already have the lengths for each road, but we were not sure. I'm not sure, is this the unit is based on the meters or feet? So what I'm going to do is, so let me move this to the right. I think that the data is based on feet, but let me make sure it is true. So let me add a new field and I'm gonna call it lengths. So I'm gonna have the lengths based on miles, MI, and based on double, data type, and okay. So this is going to be the length. So if I right click on that and then calculate geometry, so the lengths, so let me make sure that it's based on feet or not. So if I select the unit as feet and then okay, so the values must be the same for the previous value and the value that I calculated. And it seems like the values are exactly the same. So here is based on the feet. So, but I'm gonna have the values based on miles, and the reason is that because the speed limit is based on mile per hour, so the miles would cancel each other. So I would be easily calculate the travel time based on minutes. So here for calculate geometry, I'm gonna go ahead and convert this to miles and then okay and yes. So this is the length of each of these segment, but it's based on miles, okay? So now for minutes, I want to populate this field. So if I right click on that and based on these two fields, based on the speed limit and lengths, I'm gonna find the minutes. So field calculator, yes. So the minutes is going to be the length, which is based on the mile, divided by speed limit, which was based on uh, mile per hour. So it's the results going to be based on hour. So how can I convert this to minutes? I have to multiply everything by 60. Okay, times 60, and then okay. So this is going to be the minute, the travel time for each of these line segments. And I'm going to use this minute, this field, as the cost function in our network analysis. So you can consider lengths of each of these segments as the cost or the minutes in the future analysis. The next layer or shapefile is the block group in this county. So you can obtain the block group information from this website. Again, I provided the link in the description. So it's for the entire United States. And the reason that I use this one, because it has also population information. So I have already downloaded this information for the entire United States, and I then clipped that with the Union County shapefile. So I had the shapefile for the Union County, and which is this one, and also I have the block group Union County. Okay, so I clipped that with this one, with this Union County. So I have the information for the block group Union County. If I right click on that, open attribute table, so you can see that we have 30 block group in this county, and also for each one we have, for example, population information, population square mile, for population of each of these block groups for different races, for different gender, different age group, and so on. Okay, so I'm gonna use this one for our analysis. Okay, so from the website of Union County, another shapefile that I'm gonna use is under emergency management. We have dry hydrants. And dry hydrants or dry fire hydrants in this county provides easy access to water for fire department. So it can protect properties and also it can save lives. So I'm gonna download this one and then extract it and then move it to the same location you saved all of your data. So I already have downloaded this one and I can add it here, dry hydrant. So these are the locations of the dry hydrants in this county. Also, I'm going to create three point shapefiles showing the locations of, for example, house, uh, location of gym, and the location of the work. Okay, so from catalog here or from here catalog, if you find your data set, the direction that you have saved your data, if you right click on that and then new shapefile. So I'm gonna first create a shapefile. I'm gonna call it home with the point data type. I also have to introduce a coordinate system. So because it's unknown coordinate system, if you click on edit, so I don't know the coordinate system, I can get the coordinate system from this data. Okay, so if I click on add coordinate system, import, so I'm going to import the coordinate system from the dry hydrant, for example, add, so it's this value, North American datum state plane, and then okay and okay. So now I have the home shapefile, but it's empty, right? So I have to add, for example, one point and call it home. So if you right click on here and then select editor, so here you can edit this shapefile. So from editor, start editing. So here it says which shapefile do you want to edit. I'm going to select home and then continue. And here for create features, so if for the home, you have to select it here, and then here you can add some points. Okay, so for example, I'm gonna add a point here, and this will serve as the home. Okay, so I'm gonna have just this point as the home, and editor stop editing. And do you want to save it? Yes. So this is how I can create a shapefile. So let me change the color, or for example, I'm gonna make it larger. So this one is the location of my house. So I can create, in the same way, I can create another shapefile showing the location of a gym and also the location that you go to work. So, so again, I can do that, but I can just copy this shapefile and just change the location. So for example, for home, I'm gonna copy it and then right click and paste. So home copy, I'm gonna call this gym, and for gym is here. Let me add it into ArcMap. So I have the gym here, but it's the same as the home because I copied that. So from editor, start editing. So I'm gonna select gym and then continue gym here. So let me turn all layer off. So here is the gym, right? So if I wanna move the location of gym, for example, I'm gonna put it here. I use this one, edit tool, select the gym, and then I move it here. Okay, and then so if you're happy with this location, doesn't matter where you put the gym, and then stop editing. Yes, so this is going to be, so this is the location of house, this is the location of gym, and also I'm gonna create another one for the work. Okay, for example, from gym, right click, copy, and then paste it here. So it's gym copy. So this one is gonna serve as the your workplace. And so let me add it here, close. So we have everything. We have the work is the same as gym. I'm gonna modify it, the location. Editor, start editing for the work, and then continue for the work. And I'm gonna move it. Oops, not for the here. Let me clear selection. So Union County, I'm gonna move it, for example, to like this area. Okay, and then editor, stop editing and save it. So let me change the symbology. For example, blue color is okay, and then make it larger. So this is the location of gym, home, and work. Okay, so and these are the location of dry hydrants. And so these are the data set that we need for this lab. Okay, so now we have everything ready. We have the data set ready. So the first step for network analysis is that we need to configure the network analyst environment. So from customize menu, if you select extension, here you have to make sure that you check on network analyst extension and then close. And after that, you need to, let me close the editor. I don't need that anymore. After that, right click on the gray space and then select Network Analyst. So we have the Network Analyst extension here. And here are the functions that we talked about already, but they are disabled. And the reason that it's disabled is that we first need to build the network dataset. Okay, to build the network dataset from a catalog. So if you right click on the road layer, so let me change the name this to roads. Okay, so if you right click on the roads and then new network dataset. Okay, so in this network dataset wizard, so here you can specify a name for your network dataset. So ArcGIS automatically added ND, which stands for network dataset, to this shapefile of the roads, but you can change it, but I'm okay with the name, so I accept the default name. So click on next. We would like to, in this lab, we would like to create a very simple network data. So, but you can, for example, consider if there is any turn in your network, in the roads, you can consider that and model that in your analysis. But I don't want to do that. But it depends on the data. It depends on the field, whether you have the turns in your data or not. So again, uh, I accept the default values about the connectivity. So you can also model elevation in your data. So we're not going to do that. Very simple. So here you can, which fields represent as the cost. Okay, so we just created the minutes, so it automatically detected as a cost. Lengths also automatically detected as a cost, but also we had lengths per mile, right? So this one is based on the feet, but we're going to have it based on miles. So you have to use the exact name. You can add a field, but you have to use the exact name to add another field as a mile. Okay, so let me look at the name. So the name that we created was lengths underscore mi, and it was uppercase. L was uppercase. So again, if you go to the catalog, right click on roads, new network data set, next, 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 and then here I can add lengths underscore mi, and the unit was miles, and then okay. So I have added another one that I can use it for further calculation as the cost, and then next, travel modes. So we don't need these settings. Click on next, and again, you can consider driving directions. For example, is this a one direction street or no? But again, we were gonna keep this very simple, but it's possible to consider and model these complexities as well. And then finish. So it asks, the new network dataset has been created. Would you like to build it now? Yes. And then do you want to add it to the arc map? Yes. And then close. So as you can see, it created network dataset, and it added junctions, which are the vertices, and also added the edges. So here are edges, which are the links. So I don't want to, because it's very complex, so let me turn this layer off. And also, so this one also, I can remove this one as well. And for the roads, let me use a better color. Okay, so these are our roads, and also here is the location of the home, here is gym, and also here is for the work. So after you create your network data set, if you go to the catalog, you can see that a network data set has been added, right? So after you create your network data set, you'll notice that the network analyst functions are now available. They were not available, they were disabled, but after you create your network data set, they will be available. So let's begin our analysis. So the first one is new route analysis. And according to GIS, the route solver finds the shortest. Shortest path is based on the distance, or quickest path is based on the minutes or time, or travel time between two or more stops. And the solver can reorder stops to find the optimal route, which is known as the traveling salesperson problem. Okay, so we're gonna select the new routes, and when you click on that, you'll notice that in the table of content we will have a layer called route. It has multiple parts. So if you minimize this segments, so we have the stops, we have the point barriers, we have routes, line barrier, and so on. Let's say I would like to drive from home to work, but at first I want to drive to the gym. So I want to minimize the travel time from home to the workplace, but I want to have a stop in the gym. Okay. So from Network Analyst toolbar here, if you go ahead and select Network Analyst window, here you are able to tell ArcGIS what are our stops, and also the route is going to be the result of our analysis of the route analysis. Okay, so I'm going to introduce the stops. Okay, so how can I do that? If I right click on the stops and then load locations, so the first one is going to be, our first stop is going to be from home, right? And then here, because the home is not necessarily on the network, so we have to connect it, we have to snap it to the network. So if I click OK, so here we can see that the first one has been added, which is the location of the home to the network. Okay, so and adds the value of 1. So if I repeat this process, load location, again, gym is not necessarily on the network. I can select it here and it will snap. So here is a snap tolerance. It will snap it to the closest location to the network. And then click OK. So it will be added to your network. And then also right click, load location, and finally the location of the workplace, and then OK. So now I have the location of the home. So let me change the name here to home. And the second one is gym. And then I have the location of work. You can also have point barriers, you can have line barriers, you can have polygon barriers. For example, if you have bridges, you have checkpoints, so they can serve as the point barrier. For example, if you have rivers, international borders, these are going to be or your line barriers. If you have military zones, if you have forests, so they may consider as the polygon barrier. But we don't have this kind of information in our study area. However, you can, if you have this information, you need to add them to your network. All right, so after you loaded the points onto the network, you need to click on route properties, okay? So I'm going to find the shortest, or sorry, the quickest distance. So here I'm going to, let me change this to the quickest. Okay, it's gonna be based on the uh, minimum travel time. It's not based on the distance, it's based on the time. So quickest route, if you click on quickest route properties, and in the analysis setting tab, I'm going to consider the impedance is going to be your cost field. I'm going to consider the minutes as the quickest as the cost. But sometimes you may prefer to minimize the distance. Okay, for example, for walking, if you want to minimize walking distance, you may prefer to use the shortest path, shortest distance. Okay, but for example, most of the time for driving, we normally prefer quickest path. So the minutes is going to serve as the cost or impedance. So here is based on the minutes. We're gonna look for the quickest path. And so here we can say that the U-turns are okay, are allowed, and everything looks good. So the unit is based on the miles, and also the time is based on the minutes. I am going to find the accumulated lengths in our final report, and also the minutes, accumulated lengths and the minute, and then apply and okay. So now everything looks ready. So now if you click on solve button in the network analyst, so it will find the shortest route from your home, which was point 1, to the work, which was point number 3, right? And here we can see that the route is now, one route has been added. So if you expand this one and right click on that, and then if you select direction, so it will show you direction step by step. The total time is 26 minutes and the total distance is 23 miles. So it says step by step the direction that you need to take. So start at home, then go to this route, turn right, turn left, and until you arrive at gym, okay? And then you depart gym and then go to the, I don't know, to the north, left, and until you finish at work, okay? So the total time is 26 minutes and the total distance is 23 miles, okay? So it's step by step tells you the direction. So this one was the quickest route from point 1, which is home, to your workplace, okay? But the quickest route is not necessarily the shortest path, okay, or the quickest distance. So if you want to, let's compare this to, okay, so from network analyst, I'm gonna add another route. So this one is going to be, this is not the quickest route, it's gonna be the shortest. Okay, it's based on the distance. Shortest route from point 1 to point 3. Okay, so here again you can see the stops, point barriers, and so on. So for the shortest route, so again the stops are the same. I'm gonna use the same settings. So the load location, first I'm gonna load the location of the home, and then okay, and after that I'm gonna load the location for the gym, and then okay, and then I'm gonna add the locations for the location of the work, and then okay. So again, I need to, if you have any point barrier, line barrier, polygon barrier, you can add it here, but we don't have it. And click on shortest routes properties. So here it's not going to be based on the minute, because I'm looking for the distance. I'm going to minimize the distance. I'm not going to minimize the minutes. So I'm going to select the lengths per mile, and everything is the same. I'm gonna find the lengths accumulated, the total lengths from point A to point 1 to point 3, and also accumulated minutes, and then apply an OK. And now if I click on solve, so it will show me another path. Okay, so from 1 to 2 is the same, but from 2 to 3 considers another path. For you may be different. Okay, so for you maybe may take another distance, another route. Okay, but again, if you look at the routes one settings, right click on that and then directions, so it will show you, so the total distance is 23 miles now. Okay, but the travel time is 27 minutes. So the travel time is not minimized, but the travel distance is minimized now. Okay, so this is going to be your shortest route. And again, for the directions for the shortest route, again, it gives you a step by step what you should do. Okay, from location 1. So here again, you can change the location 1. You can change it to home, and then gym, and then work. From location 1, turn left, right until you arrive to location 2. From location 2 to location 3. Another thing is that, for example, we can change the order. Okay, so here location 1 to 3. Let's say I'm at work and then I'm gonna go home. Okay, maybe the distance is different. Okay, so sometimes it can be different. Okay, so I'm gonna have the gym as the first one. So you can change the order. So this is going to be the first one. This is gonna be the second one and third. And then if you run the analysis, probably you will get a different result. Okay, so now let's move on to the next function in the network analysis, which is new closest facility. Okay, so from network analysis menu, if you select new closest facility, and according to ArcMap for the closest facility, it will find the cost of traveling between incidents and facilities and determines which are nearest to one other. Okay, and the output includes a ranking of facilities by list impedance to or from incidents. Okay, so let's say there was a fire in the house. Okay, so here, let me change this closest facility. I'm gonna change the, let me turn all layer off. Work, gym. So here I'm gonna change this to the name to fire. Okay, so let's say there was a fire in this house, and change the color to, I'm not gonna confuse it with red, so I'm gonna use this color. I'm going to find the closest fire hydrants for firefighting. Okay, so I have the location of the dry hydrants. It's based on the traveling time. Okay, it's based on the road travel. It's not just based on the distance. It's based on the available roads. From network analyst, so here you need to tell network analyst what is your facilities and what is the incident. So definitely our facilities are going to be the dry hydrants, and our incident is going to be the fire, which is here. Okay, so the facilities, how can I load the facilities? Right click on that, load locations, and here I'm gonna tell that dry hydrants are the facilities. Okay, and if you click OK, so you'll notice that 59 locations will be added to the as the facilities. Okay, and also the incident, which is our fire, which is here. So if you right click on that, load location, and then here is going to be the fire, right? And then OK. So here's the color is the same. So let me change it to different color. If I right click on that, properties, and one, I'm gonna select red or this one, and then OK, apply and OK. So let me clear selection. So here is the location of fire, and here is the, let me uncheck this one. So here are the location of the fire on the network, and also we have loaded the facilities. Now they are on the network. Again, now click on closest facility property, okay? And here again, you have to set the analysis setting. So I'm going to find the closest pass from facilities to incidents, right? So the impedance is going to be based on the minutes. And here it says how many facilities, how many dry hydrants you want to find. So we would like to find, for example, 4 closest facilities. Okay, so here I can change the value to 4. And here, travel from, so we're gonna travel from facilities to the incident or from incident to facilities. Definitely, we're gonna travel from the facilities to the incident, okay? So here I'm gonna consider the facility to incident. So here also it could be based on the distance, okay? So which one is closest to the fire? So I think the distance makes more sense. And then if you go to the accumulation, you can check the lengths based on miles and also the total minutes and total lengths, and then apply and okay. So the next thing is that you need to click on solve to run the analysis. If you click on solve, it will show you it has to show you 4 under routes. Okay, so we have incident under route. You can see that 4 routes have been detected. So here is going to be, if you right click on the routes, because all of them are in the same color, I'm going to change the color to properties, symbology, categories, and then I'm gonna use this one, facility rank, and then add all values. Rank 1, 2, 3, 4. I can also increase the width of the line. So if I click on symbol, properties for all symbol, and then I can increase that. So the red one has the highest, is the closest one. So these are the top 4 facilities that are closer to the location of the fire. Okay, so apply and okay. I think, so if I change this, so routes, properties, probably for the red one, if I choose, for example, black color, I think there is overlap. So the reason is that I think that there is an overlap from here to here between red and blue. So if I use, for example, black color, and if I change for the red, so it changes to black, it shows that the best route is from here to here, or the closest facility. So for the routes, I'm going to right click properties, and then for the red one, I'm gonna change this to black, and then okay, apply, okay. So here you can see that. I think what should I do is that I have to remove the color for the blue. Okay, so let me, for the blue, change the color to for example, oh, not so like this, and then apply and okay. So yeah, as you can see, so here is the most important one. So the shortest pass is first is the black one, and then is this orange, and then green, and then the blue. Okay, for example, for the black one, if I right click on that one and then direction, it shows you, so it's 2 minutes distance and 2 miles. Okay, and but for the black one, and also for the blue one, if I right click on that direction, So it's 3 minutes and also 3.2 miles. Okay. So in order, so the first one is as the closest one in terms of the distance. So because here is based on the closest distance. So the cost that we set was based on the distance, not based on the minutes. Okay. So another scenario is that, for example, we have the location of the fire stations, and we would like to see which one is closest in terms of times to the location of the incident, location of the fire. Okay, so this analysis can be very helpful when your study area is very large in metropolitan areas, that the road network is very complex, and there's a fire, there are multiple fire stations. You want to find the minimum distance or minimum time for traveling. So this analysis can be very helpful. Or another example is, for example, finding closest hospitals to an accident. Okay, finding closest police cars to crime scene, finding restaurant to your address. So these were some examples of the application of the network analyst closest facility. And in the next video tutorial, we will continue our analysis for other functions in network analyst toolbar.